Hi, my name is Kanan Thuraisamy. I have prepared this video to give some guidance in regards to your second assessment. Um, as you can see, the purpose of this second assessment is to gain some understanding of exchange traded funds and in general, and then specifically apply your knowledge to selected funds. Um, Basically, these are funds associated with individual countries, targeting their stock index, whether it's the German market, Canadian market, the US market, or the Australian market. You have been given the underlying index as well. Um, and in addition to that, you have been given the price associated with 9 selected funds, um, um, capturing the performance from 2015 to 2019. So part 1 requires, given that the exchange traded funds became a disruptor to the industry, talk about the evolution of exchange traded funds as a general form of fund product, and then specifically focus on these funds. You can do your in-depth research by targeting these specific funds. We have also provided specific information captured on a particular date, um, about their performance, the profile of the fund, the performance of the fund in terms of return, relative measures, the beta risk measures, and also the income component, then the holdings, the type of assets they hold, and we have also given the percentage on that date. In addition to that, we have given the allocations. Say for example, this particular fund, this is the fund that targets the Australian market. It has a particular allocation, 93% towards the Australian assets, and then 2.28% UK, New Zealand, and so on. So just pay attention to these things and give give an informed opinion about what these pages means. So if you see, you will see we have provided 4 screenshots. One about the profile of individual funds, then the second screenshot is about the performance, the third screenshot is about the holdings, then the fourth one is about fund allocation, and the fifth one, there are 5 screenshots. The fifth one is about risk analytics. Then we move to the second fund, and again we provide 5 Bloomberg screenshots about covering performance, holdings, allocations, and risk analytics. So all you need to do is you need to just use the definitions we have provided. For example, here we have provided the definitions associated with the particular elements in those on those screenshots. So have a look at that and say, for example, fund type. Under the profile, it describes what type of fund it is, and provides some brief explanation about the purpose of the fund. Then also you will see under asset class. Let me just bring that, if I can draw your attention to this um, first one. So you can see this fund type is just the exchange traded fund. Then asset class, it targets only the equity asset class. Some funds target other asset classes such as fixed income, and so on. And then the market capitalization, it targets the large caps stocks, and it's a value weighted fund. It's a strategy. And then geographic focus is on Australia. So you just build a story um, using these screens. That's all. You're not required to be you know very much um, you don't have to go into too much details, but just build a story. If someone is having a conversation with you, give an informed view about what these screens means. Individual funds, relating to individual funds, so talk about you know these aspects with respect to each individual fund. That will give a nice story about individual funds. So in the first part, you will talk about exchange traded funds in general, and then you will move on to individual funds, whether it's AU equity or the US ETF or the German ETF. Just talk about what they are and how these allocations have taken place, and you know the type of objectives they have. So that is about part one. That is so you also need to visit their web pages. So wherever you can gather information, then use that to build your case for part one. That is 15 marks. So it's half of that is allocated to half of your 30 marks is allocated to this to part one. Part two is all about testing your theoretical application side of your theoretical understanding. Again, we have given these 9 funds and their prices, also the underlying indices. So what you need to do is you need to come up with some of the statistical measures, such as the basic descriptive statistics, also the correlations between individual funds. You can capture the relationship between the correlation between individual funds, and also the correlation between individual funds and other 9 indices, or the selected indices, whether it's the German index, or the US index, or the Australian index. So you just build that correlation table using the Excel function. That again is, within 2 minutes you can complete those correlation matrices, correlation matrix, and then you can go on to do your optimization. So the main focus of this video is to provide some guidance on the optimization process. So in order to do that, what I have done is I have selected I have done some spreadsheets, and also provided some step-by-step guidance on how to build those how to build this equally weighted portfolio platform so that you can use that platform to conduct your optimization. Okay, let's go through that in detail. All right, so if you look at this, I have prepared this solver optimization spreadsheet using only 8 funds. You have been given 9 funds, so it is your responsibility to include 9 funds and prepare this optimization platform, which is basically you can closely follow this guidance I have provided and build. This is a subsample of the data. This only runs up until 2018, but your data covers from 2015 to 2019. So this is a subsample of data I have used to demonstrate the way in which you build these optimization platforms so that you can build that efficient frontier that we discussed under topic 3. So the first step is to organize your data and generate this continuously compounded return, the log return. So it's simply you take the natural log and divide the current return, which is B3, this is the first fund, by the previous day's price, current price by the previous day's price. That gives you the continuously compounded return for day 1, which is the 11th of November 2015. And then what you do is you copy these and paste across, first build that first column and then copy these and paste across here for all these individual funds. You will have this spreadsheet within a couple of seconds, this return spreadsheet. The next task, having generated the returns, log returns for individual funds on a daily basis, you want to see the average return. So use the average function from the Excel functionality and work out the average return. This average return tells you is treated as the expected return. This is like as if you are you have been given this data from 2015 to 2019. You are forming expectations given the past history. So what you argue is that the average return over the last 5 or 6 years is meant to be the expected return. So that we regard it's a sensible way to approach it. So we have generated these average returns, which are really the expected returns with respect to individual funds. Having done that, the next step is to prepare the variance covariance matrix. So in order to prepare the variance covariance matrix, because what we want to do is we want to create that optimization platform. So in order to create the variance covariance matrix, what you need to do is you need to generate the excess return matrix as the first step. So if you look at the guidance here, so first you generate the continuously compounded return, then you also need to check if data analysis is part of your is already loaded on your Excel. If not, you need to go to the functions. You need to do the add-ins, where go and add the analysis tool pack, and this will give you this add-in option, and select all these solve add-in and analysis tool pack VBA. Then OK it, then you will have your solver. This is if you don't have solver under this data tab. Having done that, now we discussed about generating the log return. Now we go generate the average return to tell a story that this is the expected return, that this is the return that we expect from this given fund. So is the case with other individual funds. So we have generated this expected return. The next step is to come up with the variance covariance matrix to prepare the optimization platform. In order to do that, we take the excess return path. So you need to generate the excess return with respect to each individual return. So all you need to do is you take the individual return. So if you let me just pull that spreadsheet. If you see here, this is, we are talking about J3. J3 is what? J3 is this return, J3 minus 706. 706 is the average return that we have generated. So all you are trying to do is you're trying to show how each individual return deviates from the average return. This is simply how we make the we generate the excess return matrix. We would have done this with individual assets. Now we are doing it with multiple assets involving a number of observations. So this is the way to do that. So you copy this across this column, and then copy column R and paste across, and you will get all the excess return matrix in one shot. Okay, having done that, having generated the excess return matrix, then what you need to do is you need to generate the transpose matrix. Okay, so the next step is to create this matrix transpose using the Excel function. Here, this is the transpose. This is the Excel function to transpose the matrix. So all you need to do is you need to multiply the row by column matrix by the column by row matrix. So we have 8 rows. We have first in this matrix we have 703 rows and 8 columns. We also flip that around, and that's what this transpose function does, in such a way that we have only 8 rows and 703 columns. So having done that, we have 2 matrices, one with 700 columns and 8 rows, and the other one which is this one with 8 columns and 703 rows. See, having done that, we multiply each other to get this where is that? This transpose matrix. So essentially what you do is the first step is to select a blank cell, because we have 8 by 703 and 703 by 8. Eventually we will end up with 8 rows and 8 columns um, with the third matrix. So all you need to do is you need to highlight that, that is step 1. Highlight this area where you want this transposed values to be, and then what you do is then select a particular cell here and put the equation equal m alt bracket starts transpose, then go and select the first this one, R3 by Y705, then again select it, it will automatically transpose. And finally what you need to do is with the area selected, you need to type you need to press control shift and enter. It will automatically produce all the values as below. Try that please. Having obtained these values, then we need to make sure that these are apportioned to daily forms. So what we do is we divide it by, there are 703 observations, so we 703 days, so we divide that by each value by 703 observations. So if you look at here, this is the transposed matrix. Then if you see here, we divide these individual values by 703 to make it as daily values. So now you have the variance covariance matrix in as a single matrix here. All you see is along the diagonal line you have the variance, XIC Canada co-varying with XIC Canada, which is the variance. All the upper diagonal terms are the covariances, and the same way all the lower diagonal terms are the exact covariances. If you see here, XIC Canada co-varying with SSO US produces this value. If you see the same SSO US co-varying with XIC Canada, where is that XIC Canada? Yeah, this is the one. This is XIC Canada. You see the same value. You can test with any of those things. Say Australian fund with the Canadian fund is 2.709. If you see here under the Canadian column, it's the same value. So all the upper diagonal terms are repeated here. So this is the variance covariance matrix. We need to have that because we need to produce the portfolio variance. So the next step is to make sure that you create that equally weighted portfolio. So it's there. I have here selected 8 funds. So what it means is that 1 divided by 8 gives me 12.5% across each asset. So I invest the entire fund. So 12.5%, 12.5%, and the sum of that is equal to 1. Make sure that you maintain this as a formula. If you don't maintain this as a formula, this whole thing will not work. Then also, what having created the row vector of weights, which is basically the percentage that you invest with respect to individual funds, you also need to cell reference them. So if you see here, this is the first, the percentage invested on XIC Canada has been cell referenced here because this is the row vector of weights, this is the column vector of weights. You will see equal S727. Similarly, equal T727, which is the percentage invested on SSOUS. This has been cell referenced here, so you need to do that individually for every fund. When you have done that, you will have these values, 12.5%. All you need to do is just cell reference it, equal, then click on it. It's immediately cell referenced. Having done that, we bring this average continuously compounded return from the original return matrix here. So these are the expected returns, so we bring them as the expected returns here. So you can see for the first fund, XIC Canada, the expected return was 0.0002997. The same values here, 68. But you know, the position is for, I think, 20 digits. So you can have a look at the value. So make sure that you bring all the other values, and then you multiply the individual allocation. This is 12.5% is invested on this fund, so this times this, and create the third column, the column AC, as the weighted return. Percentage invested, expected return, so weighted expected return, and sum of that is the mean portfolio return. When you sum it up, you can see sum AC 719 to AC 726 produces the mean portfolio return. What it means is that this is the equally weighted portfolio return. Now the second step is to work out the portfolio variance of this portfolio. So in order to calculate the variance, you need to use this Excel formula, MALT. So all you need to do is you need to capture this matrix as this row vector of weight, which is S727 to 727 to Z727. That is these row vector of weights. That is what you see in the first one, first element, comma, MALT again. You capture this S719, this entire variance covariance matrix, 719 to Z726, multiplied by the column vector of weights, AA719 to AA726. So if you practice this by applying this formula, that produces this portfolio variance. That's how you produce portfolio variance when you have multiple assets. You can't just sit and do the calculation using the calculator, because it's going to be a very difficult exercise. So you just use some matrix multiplication principle. So Excel is a spreadsheet, so you can use any other program, R or anything, MATLAB or anything. Simply for this exercise, we can use Excel to work out the portfolio variance. Again, because we are dealing with daily values, so this is the daily portfolio variance. Then you can annualize it. You can take the the square root of that, which is the daily standard deviation. Then you can annualize it by taking the square root of time and multiplying that the portfolio standard deviation, daily standard deviation, to generate the annual standard deviation. Having done that, Now what we want to do is, this is the portfolio daily return, uh, the return of the equally weighted portfolio. Now we want to see how, if we want to achieve a target return. Now target return in daily form, from the assignment, you would have seen, where is that? Okay, you would have seen I have asked you to use different target returns, 2%, 3%, 4%, and so on. You can even use 1% and 30%, whatever the percentage, but make sure that you maintain these percentage at least. And I have selected 10% as the case here, to explain this whole optimization story. So if you look at this 10% here, what I have given is in discrete form, but what we are dealing with is in continuous form. So you need to make sure that this 10% is converted to continuous form. So it is simply equal ln 1 plus that 10%, so 1.1 produces this percentage in continuous form. But then you remember, these are discrete returns in annual form. So what you want is in daily form. So this annual continuously compounded return must be converted to daily return. So I have used 260 days. You can even use 252 days, depending on which assumptions you make. In the US convention is that 260, so use 260 or 252, it doesn't matter. But here I have used 260, I should have used 260 throughout. Or if I'm using 252, I should use 252. So I can change that even, but let me not change it at this point, but just make sure that you maintain this consistency. Okay, so the target return, daily target return is 0.00036666578. Having done that, what you want to do is, the next step is to optimize it. So now you have come up with this optimization platform. All you need to do is you need to optimize it. Okay, in order to optimize so what you have done is you have blindly allocated individual equal weight towards individual funds. So what you want is an efficient way, by considering the risk and return associated with these individual funds. You want to optimize in such a way that the best possible asset is chosen and the maximum percentage is allocated. So in order to do that, what we need to have some optimization engine. So Solver provides that facilities, that ability to do the optimization. So leave the cursor on the portfolio variance, because we are trying to minimize the portfolio variance. Click on Solver. If you have not got Solver, then you need to go to that functions, follow those steps and work out this. All what we are trying to do is we are trying to minimize this AC730, which is the portfolio variance, by rearranging all the weights. So if you see here, by changing the variables in the cells, we have allocated 12.5%, 12.5%, 12.5% across all 8 assets. What we want the engine to do is reallocate it in an efficient way so that this portfolio becomes an efficient portfolio. In all likelihood, this equally weighted portfolio is bound to be an inefficient portfolio. So, so what you do is, let me just do it again. You are trying to minimize this by selecting these weights. Hang on. Okay. And then you need to add constraints. One of the first constraints is that all your funds should be invested across these 8 assets. In your case, it will be 9 assets. So that the totality of the fund is represented here. Sum of all your funds, 12.5%, 12.5%, all of them added together is 1. So MAF727 should be equal to 1. What it means is that all your funds should be invested. So if let me just delete this and add this. Okay. So what did I do here? That's wrong. So I should be this one. Okay. Let me delete and show you how to add the constraint. So in order to add a constraint, the first constraint is that all my funds should be invested fully. So we should be fully invested. So MAF727, which sums up all the that idea of investing fully, should be equal to 1. And then having done that, add this constraint. Where is that now? Okay. Cancel. Now you can see MAF727 is 1. Similarly, you can, the next constraint is that AC729 should be equal to AC727. What is AC729? AC729 is this one. The target daily return should be equal to AC727. Okay, the target daily return, this one AC729, which is the target return that we want to achieve, should be the portfolio return. Currently, the equally weighted portfolio produces 0.00037. We don't want that. What we want is, we want this to be this return. So we instruct the system to produce that return so that you rearrange all the portfolio weights. And also the third constraint is that all these weights, the row vector of weights should be greater than or equal to 0. That because the assignment says, if you go back to the assignment, you will see that assuming short sales are not permitted. So we don't permit short sales. So that is a constraint. So that means any of these weights, 7272, S7272, Z727, any of these weights should be greater than or equal to 0. So that means you cannot short sell any of these funds. So those are the 3 constraints. By default, it is a GRG nonlinear solving methods, and leave this make unconstrained variable non-negative, leave that, and this is the engine, so solve it. When you solve it, it will produce okay. Now it has produced these solve results. So what you need to do is you need to be carefully, because now you can see it has reallocated all the percentages. You want to restore that because you don't want to damage this optimization platform. So you want to keep it intact. So restore original values, answer, click on answer, and OK it. Then it will produce all of those things in an answer report. This is the answer report. If you look at here, I have prepared all the same thing in the original sheet, and you need to generate the daily standard deviation. You can see the square root of that, then multiply by the square root of time. You produce the annualized standard deviation, bring all the daily returns and multiply. So you can see originally we had the original value of 6.25271E. That was the original value with a equally weighted portfolio. Having optimized it, we have produced a daily standard final value of 3.887, which produces a daily standard deviation of 0.00623, and in an annualized form it is 9.89%. If you go back to the Solver optimization, you would have seen original equally weighted portfolio had a annual standard deviation of 12.55%. Now with the optimized results, we have a reduced standard deviation of 9.89. Then also, we know it, we targeted the annual portfolio return. It was 10%, and some of that produces this value. Okay, so you need to right, this should be 9. Let me go back to the Solver optimization. Because of the error I introduced, it should be not 260. Let's divide it by 252 to maintain that consistency, and then it should produce the same value, 9.9. Let me try again. Solver, close. Okay, anyway, so this should produce the same target return of 9.53. I'll do it again and show you the class. So that is all about the Solver optimization. All you need to do is you need to target these two figures, take the annualized standard deviation, take the annual return, and list that for 10%. Then repeat the same process for the next percentage. Let's say 2%, 3%, and so on. So what you will have is you'll have 15 different answer reports with individual percentages. So make sure that you name it as percentage, because you need to upload this Excel spreadsheet as well, so that we see what you have done, and you'll have all the individual returns. So this is how you optimize it. Let me just go through this in the class as well, so that um, you'll have a better take on it when you are prepared. Okay, so that's all for the time being. So um, I will upload this video and just go through this, please.